Hello and welcome to a readout of an intelligence POC that we've done here at Data Squared Research Development and Investment. Just a quick note about who we are. John Bruton, our Chief Executive Officer, spent time with the Air Force, Chevron, and also AI companies. Chris, a Navy SEAL, last part of his career he was the chairman of the Joint Military Operations at the U.S. Naval War College. Myself, Jeff Dalgleish, 17 years with Chevron and an AI company after that. Eric graduated from a Harvard Business Analytics program and also was a U.S. Marine and has worked in South America on a whole bunch of mining projects. The data set we're going to look at today, or we were given to take a look at, was it's not a real data set. This is fictitious. It was given to us by Ed Waltz, an adjunct professor of strategic intelligence at the Patrick Henry College. And just to level set what data you're going to be looking at, so it's really understanding events between March 6, 2021 and September 30th, 2021. The area of interest is Afghanistan and Pakistan. And we really have three main sources of information. There's intelligence information, which is intelligence from multiple different intelligence systems. Signals intelligence, which is really telephone information, who called who and for how long. And financial intelligence, which is bank accounts and how much was transferred. So really solving the problem of what happened with this big set of data. We're going to bring all the information into our system. We're going to turn it into events, and we're going to extract things from it. We're also building large language models that will help do these extractions so that we can get very specific about what types of questions we're asking this data. So with large language models, we can actually ask questions of the data and get answers. So we're going to be storing those answers in our knowledge graph, which is sort of our secret sauce. So the mission here was to understand what was happening. So we're going to identify entities to be investigated, and we're going to deploy an AI to assist with the investigation. So really, the initial part of the project was ETL. So there's 3 data sets. So we extract it and we run it through our system. And that basically loads it into a knowledge graph, extracts all of the relevant pieces of information, and kind of gets it in a form that we can start doing investigations with it. So for this example, I'm going to really just walk through an investigation into the death of one of the informants named Janek in this data set. So I'll sort of show you how a user might dig into this a little bit more. So what I'm going to do is I'm actually just going to jump over to the software. Let me just clear the screen here. So we're going to start with a blank screen. So we're going to start off with what do we have in the system. Let's take a look at the evidence. So the evidence is sort of the base piece of information. Each one of these little dots here is a different thing that happened. So it's different little pieces of information. You can see where it came from. You can double click on it. You can see what evidence and the evidence text. You can look at what it's connected to. We'll see a lot more about this in a bit, but this is all the metadata and just how these things are all connected to each other. When we extract, for example, people's names, they get stored in here. So let's add something to this graph. It's a little bit boring right now. So let's put some people on it. So some persons. Push the button and the persons get added to the graph. So now we can see which people are connected to which pieces of information. So we can zoom in a little bit just to kind of see how, at a high level you can move things around and kind of organize your information a bit better. So here's sort of a branch that might get interesting here in a second. So this is some information, different people, how they're connected. Let's add country to this to kind of add a little bit more context to what's going on, I think. So I'm going to get rid of people and just add country. So now we're going to go and take a look at if the country was mentioned in any of these different pieces of information. So if I zoom in, we've now organized the information by country, so we know what's happening in Pakistan, what's happening in Afghanistan, what information is connected in Afghanistan, different types of information. Okay. Let's add to this also the banking information. So we're going to put the banks in here. So if any of these pieces of evidence referenced a bank, now we can start to see more of a picture developing here. We're going to zoom down here to this part. I know the story already, so I can zoom in a little bit. But what's happening here, I just want to focus on this one piece of intelligence right here. So the intelligence is a highly reliable source. Janek has verified with medium confidence that Hamad Dazari is financing a large number of COSID operations using an intermediary, Jamal Saab, to transfer funds. Saab's bank accounts are UA54 blah 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 and JH and a bunch of numbers. And then at the bank, Janok reports that financing is sourced to organization CX. So a lot of information in this piece of intelligence. So we might want to understand where did this Janok character, let's find out, let's add the sources to the graph. So anytime a source is mentioned in these graphs, they should be annotated. So I moved around a little bit, so I just have to find my way back to it. Okay, I just reorganized the graph a little bit to make it easier to read, but sort of we're in the same spot. This is that piece of intelligence we were looking at with the bank accounts. And what we've done is we've brought in this source. So this is a piece of information, and it says a highly reliable source, Janok. So this is this Janok person. This is also the person that was killed. So there's a highly reliable source, Janok was killed in unknown circumstances in the vicinity of this other person. So we can, this reference of the evidence also points to this other person. So we can maybe want to investigate this person a bit further. So that looks like there was some surveillance that was done on them. So you can really just start seeing how these things are connected. For example, here, this person was mentioned in some other intelligence where they did talk about IP addresses. So what we could do, we could just add to this. We could add, this node actually has IP addresses connected to it. So I could add that, and we could actually highlight what those IP addresses were. So we might want to start further investigations with this information. Okay, I've just cleared the screen. I want to show you another way to interact with the system. Let's say I want to go through a topic like chlorine. So I can just choose it from the list. I also want to see how this tool chlorine is related to, say, evidence in the graph. And to make it a bit more understandable, let's put the date in there as well. So now we're going to get a graph of what happened on what date when they're referencing chlorine. So let's just organize this really quickly. So April 3rd, April 6th, and then August 21st. So let's move this over here. Sorry, it's all backwards. There we go. Okay, so August 3rd, there was a a mention of chlorine, a possible attack. On the 6th, it looks like there's some IP addresses that were searching for it. And then on the 16th, it looks like there was a very big attack where 27 killed and 60 injured. So it looks like something was planned. So let's take a look on this April the 6th date. I want to be able to see from this intelligence information, it looks like there's some IP addresses there. So let's expand that, and let's take a look at those IP addresses to see if we can find them anywhere else. Okay, so now we've got those 3 IP addresses, and on each one of them, we can take a look at it, and we can see that this one here actually has additional nodes attached to it. So there's additional pieces of evidence that are linked to this IP address that was involved in potentially searching for this. So we can see here, looks like there's some emails. We've got an IP address, and then another one over here. So it looks like we have a little bit of more information about what potentially was going on here. So it's really building the picture up from a topic as opposed to starting with everything. There's so many ways to interact with this graph. It allows the people using it to be very creative in how they address the data and how they approach the data. So that's really the end of the overview. I'm going to switch back to the slides really quickly and just talk a little bit about the technology. So right now, essentially the whole thing's been written in Python and Neo4j. We're going to be conducting a well-architected review pretty soon, because we really need to move this system into AWS so it can run a lot faster. So we'll be using technologies like DynamoDB, Lambda functions to run a lot of the extractions, and SNS and SQS to be able to move data in and out from folders in real time. And then, of course, to do the generative AI, we're going to need large language models, and we're going to be calling them to do extractions for us and maybe assess risks and just go in and do additional things on the data. Building models will be done with potentially SageMaker, using Textract. Maybe there's paper documentation that needs to be used. So for some of our oil and gas projects, we'll be using Textract to be able to go in and take old drilling reports, and we're really using the same system for oil and gas, but in that case we're using it to abandon oil wells used on historical drilling data. Different context, but essentially it's the same thing, just trying to figure out what happened on the well when they drilled it. We're using Neo4j, which has a whole bunch of graph data science technology that we can also add, which is already included in this. We just need to start using it. But like things like shortest path and centrality and similarity and all of the really advanced data science graph algorithms are available to us. Thank you for listening to this whole presentation.